Number 2, we're trying to figure out where the function is increasing and decreasing, and we're supposed to use the first derivative test to locate the local max and mins. So for this one, when we take the derivative, we're going to have to use the quotient rule. So it'll be x plus 1 times 2x minus x squared times 1, and this will all be over x plus 1 squared. So let's simplify this. It's going to be 2x squared plus 2x minus x squared all over x plus 1 squared. And let's see if I gave myself enough room here. This is going to be equal to x squared plus 2x over x plus 1 squared. So this is our derivative. I'm actually going to factor out the x out of the top because eventually I'm going to have to factor it anyway. So x and x plus 2 all over x plus 1 squared. So once you take the derivative, we still need to find our critical numbers. So to find the critical numbers, you want to set the derivative, or f prime, equal to 0. So let's do that. I have x times x plus 2 over x plus 1 squared is equal to 0. And I don't really have much factoring to do here, so my critical numbers now again, the critical numbers, these are where the derivative is equal to 0 or where it's undefined. So I get x is equal to 0 coming from that x on top. I have negative 2 coming from the x plus 2. And then I have negative 1 coming from the denominator. So these three are critical numbers, although if you look at the negative 1, that is undefined in the original problem, in the original function. So we actually need to cross that out. That is no longer a critical number, although we still need to keep it on the number line. So it seems kind of redundant, but we still want to keep this on the number line. So it's not a critical number because it's undefined in the original, but we still want to put numbers that are undefined in the original on the number line. They're just not critical numbers, so they won't be maxes or mins. Okay, so let's take these numbers and let's put them on the line. And we want to figure out if these regions are positive or negative. So if you plug in the negative 2, the negative 1, and the 0 into the derivative, and you can either do this manually or you can use the table. If you want to use the table, plug in the derivative into y1 in the y equals, then go to second graph to go to the table. And you'll notice that these all equal 0. So if I pick numbers that are between these or in these regions, so like negative 3, I get a positive number. So this is positive. A number between negative 2 and negative 1 would be negative 1.5, and I get a negative number. A number between negative 1 and 0 would be negative 0.5, and I get a negative number. And then a number greater than 0, I'm going to pick 1, and I get a positive number. And you don't need to pick these same numbers. You could pick 10 for the last one. As long as it's within that region, then you should be okay. So we can use this to make a lot of analysis about the original function. So the regions where it's positive, these are where it's increasing. So this is going to be from negative infinity to negative 2 and 0 to infinity. Decreasing is going to be negative 2 to negative 1 and negative 1 to 0. The local max, that's where it changes from positive to negative. It's a critical number where it changes from positive to negative. So that's going to be at negative 2. The local min, that's where it changes from negative to positive. So that's going to be 0. And then to get the y values of these, you need to plug these into the original function, not into the derivative. So if you plug in negative 2 into the original function, you should get negative 4. And if you plug 0 into the original function, then you should get 0. And that'll be our answer.